Today we're going to be reviewing exponential functions, what they are, how to find them, and what the equation would be if we have an equation. So let's get to it. So in the last few days we've been talking about lines that curve. They have a name and an equation. These graphs are called exponential functions because 1, they curve, 2, there's no constant slope that's increasing or decreasing, and there's different types of them. So one of the types, there's 2 types. We have a growth and a decay version. So as you can see, growth, if we're talking about a population, is going to increase. And if we have a decay of people dying or plants slowly dying, really anything that is decaying over time, the line is going to decrease. But here's the thing, it'll never hit the y-axis. Okay, that's super important. It'll get super duper close to 0, but it'll never hit 0. So let's look at some, we looked at types, now we're going to look at the equation. So what would the equation look like? Well, now instead of using y equals something, we're going to use this term right here. It's called f of x. So f of x is how you say it. So this is another word for y, or the start of our equation, right? So the equation, since it got kind of messed up there, is going to be f of x equals b to the power of x. So remember how we learned about exponents and how important it was to make sure that we're multiplying the base number, the b, by itself however many times the exponent is? This is where this comes in. So b is our base. That's pretty easy to remember. B, base. The number has to be positive and it cannot be 1. So those are 2 important things. Has to be positive and it can't be 1. If it's negative, then it's not an exponential function. It's something completely different. And x, this is our input value, or the x values. So if I had, let's say, x equals 2, then I would take this 2 and plug it in for x. So now we have f of x equals b to the power of x is how the equation will look. Let's go actually see it in real life and see what we're dealing with. So it says f of x equals 2 to the power of x. So if this confuses you of what the heck is this, you can write it like this, but the y tells me that that's a linear function. That's why we want to make sure that we write it as f of x equals something. So my base is 2. So what's going to happen here is, just like every equation that we've been dealing with the x's and y's, we're going to take our x here and we're going to plug it in right here where the x is. So now for this one I have f of x, f of 1, because x is equal to 1. f of 1 equals 2 to the power of 1. Well, what's 2 to the power of 1? That's just 2 times 1, which would be 2. Now we're going to do the same thing. We're going to take the 2 and put it in for the x. So now I have f of 2, because that's what our x is, equals 2 to the power of 2. Now remember, this is 2 times 2, because this exponent tells me how many 2's I'm going to multiply by. So 2 times 2 is 4. I want you to pause the video and try the last 2 and see what you get. Alright, so f of 3, if you pause the video, what we're going to do is take 2 times 2 times 2, and you should have gotten 8. Now the last one, number 4 here, I have f of 4 equals 2 to the power of 4, which means I'm taking 2 and multiplying it by itself 4 times. So I get 16. As you can see here on the y-axis, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it's increasing by multiplying it by 2. That's where the exponent comes in. So let's actually graph these. So I'm going to go, remember this is my x-axis and this is my y-axis. So I'm going to go to 1 and up to 2 and put a dot. Then I have 2 and 4. And then it's going to get crazy here. Then we have 3 and 8. See how it's getting extremely larger. And then 4 and 16. So I know it's going to be a curved line because look at my points, they're curving. But I'm going to go like this and go all the way up. And obviously I missed that last point, so I would redraw it and make sure that I hit all of the points. But it's going to be a little bit curved, so even if your curved line isn't perfectly curved, as long as it goes through those points, you are perfect. So let's go try another one. Alright, so we have f of x equals 4 to the power of x minus 1. So that means I'm going to, whatever my my x is for my exponent, I'm going to subtract 1 from it. So I have f of 1 equals 4, 1 minus 1. Now I have 4 to the power of 0. Anything to the power of 0 is 1. That one is pretty easy. Let's do 2. So I have f of 2 equals 4, 2 minus 1. You can put it in parentheses if you want. That way you can keep it consistent. So 2 minus 1 is 1. So now 4 to the power of 1 is 4. And I'm going to continue this on with f of 3 equals 4, 3 minus 1. Now what's 3 minus 1? 2, which means 4 times 4, which is 16. So see, this is kind of slowly increasing. So now I have f of 4 equals 4 to the power of 4 minus 1, which would be 4 to the power of 3, which would give me 64. Let's see, 16 times 4 is 64, yep. So now I'm going to graph it. I'm going to graph as many points as I can. Obviously, my graph won't reach to 64, so I'm just going to graph the first couple points here. And sometimes that'll happen, sometimes it'll go off the graph, and that's completely fine. Just graph as many as you can. And there we go. So now I'm going to take my line, and I'm going to curve it. It's a lot easier to turn your paper and curve it, so that way you can see, hey, this is my curve. Let's do number 3. Alright, for number 3, now we have a half. So remember, the rules that we had for our base are it cannot be 1, and it has to be positive. This follows these rules. Here's why. If I have 1 to any power, that's just going to be 1. 1 to 600,533,000 is going to be 1. So that's why we can't have a 1. So what we're going to do is we have a half now, and which is totally fine. So I'm going to take f of negative 4 equals, what's 1/2 as a decimal? 0.5. So I'm going to take 0.5 and put it to the negative 4 power. So I'm going to take, what this means is I'm going to take 0.5. Oops. Well, we don't really like fractions. Remember, we hate, or not fractions, sorry. We really don't like negative exponents, right? So this is actually going to be 1 over 0.5 to the power of 4. If I take 0.5 to the power of negative 4, it's going to give me 16. So what we're going to get is 16. So you might need to use a calculator on some of these, but we're going to take 0.5 times itself, times itself, times itself, times itself, times itself to get 16. Then I'm going to take -2 and put it as the exponent. So let's use our trusty rusty calculator. Sometimes you might need one. So 0.5 to the power of a -2 is going to give me 4. If I have 2 sets of 50, it's going to give me 4. And then 0. Anything times 0 is what? Anything to the power of 0 we said is always what? 1. Always, 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 always. F of 1 now of 0.50 is just going to be a half. Wow. So now let's graph it. So -4 and positive 16. And then I have -2 and 4. What kind of graph is this? Is this growth or decay? It's decay. It's going down. So, oh gosh, that's really bad. And remember, it's never going to hit the x-axis ever. It'll get super duper small, but it'll never hit it. So, let's move on to the last example. Welcome to the game show of Is it exponential function or not? Here's a couple things to keep in mind. The base, b, has to be positive. This has to be positive. 100% has to be. I can't have a negative base. Okay? Another thing, and it also cannot be equal to 1. Remember, we talked about that. It can't be equal to 1 because it's just going to continue on forever. And it needs to have a constant raised to a variable power. So that means a number, which is a constant, my base, raised to a power. So I have to have an x somewhere along there. So let's look at number 1. Is this an exponential function? I want you to think about it. Does it look like our equation? Absolutely. One thing I need to check, is my base larger than 1? Is my base not 1? Yes. Is it positive? Yes. So, does it have a constant raised to a variable? Well, 2 is a constant, and our exponent is a variable, the x. So, yes, this is an exponential function, because base is a constant, which is 2, and we have it raised to a power. Boom! This one passes the test. Kapow! Yeah! So let's look at the next one. F of x is 2 to the negative x. Well, we did see it a little bit earlier. Yes, we can have a negative exponent because our base is a constant. Check. It's not 1. Double check. And we have it raised to a power. Triple check. So yes, this one is a exponential function because of the same reasons. We have it raised to a power. Okay, let's look at the third one now. The third one. All right, our third one. Let's look. Do I have a base? Yeah, I do have a base. Is it not equal to 1? Yes. No. We need a constant raised to a variable power. So yeah, it's raised to the power of 2. But this 2 should be an x. I need to have a variable raised to a constant. So is this one? No, it's not. Because we need the constant raised to a variable. I want you to figure out the next ones on your own.